Hi, everyone. My name is Vasily Malanin, and I'm head of Internet of Things business development in Asia Pacific and Japan region for Amazon Web Services. Welcome to our third and final session of the AWS IoT Digital Roadshow for Asia. And today with me, I have amazing speakers from our partners. I have John Trainer, VP and GM of product from Tensor IoT, and Rob Cummins, CEO of Urban.io. We started off with an overview of the industry trends and highlighted the role of data in building insights that drive transformational initiatives. And cloud is usually used as a platform for landing these data and processing them. We have many manufacturers in Asia who are actually turning their products into connected products and even changing their business models into some subscription offering. However, the focus of this series is actually on manufacturing operations. And we are convinced that we actually need to start every conversation about manufacturing operations optimization from business outcomes. And so in manufacturing ops and smart factory, we typically talk with our customers about these top outcomes that you see on your screen. And so we talk about the productivity, quality, availability, utility cost, and safety. There are other things that are coming up, like asset tracking and supply chain and a lot of other things. But still, we feel like most of the conversations are happening, especially around first three, being P, Q, and A. And for those who are very close to manufacturing, they all know that these three KPIs, they're actually part of what we call overall equipment effectiveness. And this is the KPI that every manufacturer tracks on a regular basis and reports to the management. And no wonder why we actually tailored our sessions the way that each webinar actually tied to one of those topics. So we started with productivity, then we covered quality last time, and today we're going to be talking about availability. Next, I would say 50 minutes, I hope to hear from our partners about their solutions and their insights in this area, then to see in action in some real live demos how their solutions actually help manufacturers to increase availability of their critical assets. With this, let me give the stage to John, who's a VP and GM of product from Tensor IoT. So John, please kick it off.
Great, thanks very much, Vasily, and hello to everyone. Great to have the opportunity to share with you some interesting information. So let's pull up a presentation. And so, as Vasily mentioned, we're going to talk about availability, keeping everything running in manufacturing, and effectively achieving what we call greater situational awareness, actionable insight with assets and equipment, and then being able to make more confident decisions going forward. On that note, here are some of the things that we've heard at Tensor IoT from manufacturing and other industrial customers that we've talked to. Some will say, well, hey, we think we're fairly productive, but, we're not sure. Some of our operations are chaotic. They'll talk about having older machines and they want to be able to work with them, but they're not quite sure how. Oftentimes people will say, well, we lack empirical data to really understand what we should be doing differently to improve availability within our manufacturing operation. People talk about unproductive time, so that impacts availability overall, but customers will say it's very hard to measure. It's a challenge. They talk about, overtime costs as a sort of a factor into availability, not being unproductible. And people really also just talk about not having a great real-time view of what's happening on the production floor. That led us at Tensor IoT to develop Smartinsights, powered by AWS. It's a complete end-to-end solution specifically targeted to industrial customers to help customers rapidly connect and therefore get actionable insight, operational insight, and real business insight out of the data that's sometimes locked up and trapped on the production floor. So by combining connectivity, visualization, and analytics together specifically for manufacturing and industrial use, we've created Smartinsights. It connects machine data, and that can be from PLCs, that can be from sensors connected to equipment, that can be from industrial protocols that are built into particular machines or middleware that's already been deployed on the factory floor. Regardless of the way the data is available, Smartinsights connects that machine data to Amazon Web Services, thereby enabling accelerated insights and really increased business value, again, by liberating that data from floor operations into the cloud. So Smartinsights, when I think about the key features, first of all, it's fully ready to deploy with the hardware, the edge gateways to connect the plant to the cloud environment, and software which, very importantly, runs in the customer's own AWS account. We firmly believe at Tensor IoT that customers should own and control their own data. And so we don't want to be sending it to some other SaaS provider, but actually having it reside in the customer's own AWS account. And we think that's critical for being able to extend the solution to meet the unique needs of each particular customer. The deployment of Smartinsights software comes pre-packaged with a number of cloud-based dashboards for both operational data and business intelligence as well. So customers can really hit the ground running with that. And as I said before, the integration with a variety of other AWS services, such as Amazon Lookout for Equipment or Amazon Lookout for Vision, enables a number of different scenarios, including predictive maintenance, defect detection, and other things that will help customers improve availability, uptime, and the quality of what they're producing in a manufacturing environment. So we expect customers to be able to get factory floor data or any kind of industrial production site data hooked up and viewable in AWS in days or weeks. So this is not a months-long or years-long project to connect all of the equipment and get things up and running. We can get started in a matter of days with customers. And therefore, we expect customers to also very quickly be able to derive measurable business outcomes, including improvements in asset utilization, operational efficiency, and product quality as well. I'll give just a quick overview here, and we're going to go into a demo a little bit later. Some of the key things that can be done within Smartinsights, first of all, is that notion of having live analysis. So really being able to see what's going on the production environment, not necessarily in real time, meaning to the microsecond, but certainly we call it live data. So data that's not more than a few minutes old and is available from the factory floor to wherever somebody may be looking at that around the world. And you can get that at the right level of detail, whether it's looking at today's operation or looking back, say, over 90 days or a longer period of time to really understand what's driving availability inside the plant environment. There's a number of different ways to filter and get through that information to quickly see what's going on. Certainly, we think it's appropriate if you've got a multi-site environment to look at comparing information for like sites across a number of different plants so that you can really understand both best practices from one environment to another and also spot areas of trouble that should be a focus for additional inquiry. And then finally, having a number of different robust visualizations, not only what Smartinsights can provide, but being able to connect into a number of other tools as well. So that from the worker who's actually operating the machine and trying to maintain visibility and keep that machine running and producing output, to an executive who wants to have a global view of operations, there's going to be a visualization available within Smartinsights to meet those particular needs. So for those of you who are familiar with AWS services, and I'll just say that one of the beauties of Smartinsights is we can orchestrate all of this without needing to look at all of this in detail. But from left to right on this diagram, effectively taking information from the factory floor, again, whether that's directly from PLCs inside of machines or from sensors that have been added to equipment or from other systems, be able to bring that together and very quickly, regardless of the original data format, ingest that into the cloud using services such as AWS IoT Sitewise to very quickly be able to transform that data, add measurements and metrics to that, scale data appropriately, and be able to combine data from a number of different sources. Be able to pull all of that together and put it into a common data lake so that it's available not only for Smartinsights, but it's available for a number of other applications as well. And from that, then we can do things like alerts and notifications. And so if, for example, an anomaly is detected by a machine learning model in the stream of data coming from a piece of equipment, we can alert somebody or integrate with a maintenance system to open a ticket to suggest that a particular piece of equipment should be maintained before it breaks down unexpectedly and leads to unplanned downtime and a loss of availability within that environment. And because this is built on top of AWS, additional services can be brought into this. So for example, I mentioned earlier the use of the Amazon Lookout for Equipment, a relatively new service that wasn't available when Smartinsights first came to market. But we can now take that data from that data lake and we can run equipment data through a service such as Amazon Lookout for Equipment to do anomaly detection quite automatically and further the value that customers get from a deployment of Smartinsights. Let me now talk about an actual implementation of Smartinsights and what that would look like. We think it's very important to actually start with something small and meaningful that will actually derive value for you in your particular manufacturing environment. So it's what we call a crawl, walk, run type of approach, starting with something small, but really also having a relatively short time frame in mind, typically measured in just a few weeks. So that might be starting with a particular assembly line in a plant, a manufacturing cell, some other cluster of equipment that is relatively self-contained, but for which there is a particular challenge, perhaps related to availability, that you want to solve inside the particular plant environment. So within that first few weeks, once we've identified that initial cluster of equipment, we would be onboarding and connecting those particular assets. And if necessary, with some older equipment, adding sensors to that particular machinery. I mentioned before, we've worked with equipment as old as well. Personally, I've been involved in mechanical presses from the 1920s. And so certainly not something that had a network interface, so adding sensors to that to get readings from the equipment was very important. And that's something that can be done quite quickly and quite easily. And there's a number of different technologies that can be used to ingest that data through Smartinsights into AWS. Once we've got that data connected, the first step then is to really be able to see that data and to show that real-time or that live operational data. And then you can immediately understand asset utilization as well. So, how many hours per day is a particular piece of equipment up and running. So you can get an historical perspective and understand what's going on in the moment. And then you can, on top of that, add alerting and reporting to be able to see changes over time so that if changes are made to equipment, clearly you can see that visually in the data. But also then you can, beyond that, start to look at things like machine learning to take telemetry from a machine, identify anomalies, see adjustments made in the equipment, and then correlate that with increased availability or improved quality or whatever the particular focus is. We suggest doing all of that within one cluster of equipment within a particular plant. Now, some things can only be done across the entire plant, but certainly there is a lot of improvement, a lot of things to be learned, starting with one piece of equipment and then moving to a second and a third and across the entire plant. So beyond the first 4 weeks, typically 8 weeks and beyond, getting into adopting Smartinsights across all of the equipment in the plant. Now, if it's a relatively small plant, say with dozens of machines, that can happen very quickly. If it's an extremely large plant with hundreds or even thousands of machines and pieces of equipment, just the time to actually work through the correct reporting and visualization for all of those assets may take some time. And certainly that's where Tensor IoT's consulting services are able to work directly with customers to augment their own resources to accelerate that deployment as quickly as possible. Once an entire site is up and running, then it's really time to move on to multiple sites if your organization has more than one location, and really take the same approach in each of those sites. If it's similar equipment to the first site, then it's relatively easy to move ahead with that. Otherwise, it's starting over with a small cluster of equipment, making sure that works in the second site, rolling it out to the rest of the site, and then moving on fairly quickly as well. And with Smartinsights, we certainly are engaged with customers who have hundreds of sites. And because it's built on top of AWS, this is really something that scales from the smallest of production sites with only a few machines up to the largest of global enterprises with hundreds of plants and thousands or tens of thousands or hundreds of thousands of pieces of equipment. So when customers deploy Smartinsights, these are some of the benefits that we expect them to be able to realize. Certainly predictive maintenance is a top priority for many organizations, understanding how they can improve their scheduled or their planned maintenance to really be able to, first of all, only do that maintenance when it's actually required on the equipment, so really saving in both time and materials, not doing unnecessary maintenance, but also being able to get to equipment perhaps earlier than the planned schedule would otherwise call for to make sure that machines and equipment keeps running and doesn't break down and take down the production line all at once. That, of course, leads to improvements in operational efficiency. So really just looking across the entire plant at the percentage of time that equipment is truly running and is productive. So not really on, but actually doing value-added work in the manufacturing process, and then being able to see immediately the feedback and the direct impact of making changes in that process on all of the calculations available and visualized in Smartinsights. And then beyond just keeping the machines up and running as much as possible and maximizing that uptime, then looking at ways to really improve the process and optimize exactly how products are being developed. For example, by looking at what happens if there's slight changes in recipes or machine programs or increases in speed, and whether or not that also has an impact on product quality or anything else that might be a concern in the environment. And finally, particularly with machine learning, anomaly detection to really understand deviations from normal, perhaps before they could be detected with normal means that are in use today. So that might be looking for very subtle changes in one of the readings from a machine that is certainly within boundaries, but if it drifts up over time, that will ultimately lead to a type of failure. So by learning from the history of operations, Smartinsights can then help organizations determine when machines are going in a direction that is going to lead to some type of failure, and corrective action then can be taken before that. So those are the types of things that can be done with Smartinsights. And let me just talk for a moment about one particular customer who had a couple of hundred, actually over 200 locations worldwide, using Smartinsights technology for device monitoring together with machine learning for predictive maintenance to improve the availability of equipment in their particular operations. So this was a diversified metals service center, nearly 100 years old. Certainly they were looking for ways to modernize their operations, but wanted to minimize the capital cost of adding new equipment. They had some fully depreciated older assets that were continuing for the most part to work well, except for times of unplanned downtime. And so by ingesting all of that operational data, including adding sensors to a lot of this older equipment, they were looking for ways to reduce what they saw as their biggest problem, which was costly downtime, the lack of availability of equipment due to unplanned downtime, probably from maintenance that was missed or not understood, or they didn't realize that something in a particular piece of equipment was going to wear out when it did. So we took all of that telemetry from the sensors and other operational data, leveraged a number of machine learning models so that we could detect as a predictive indicator when a machine was showing anomalous behavior. We're able to then integrate with a dispatch system for maintenance personnel on the shop floor to be able to go out and service that equipment, whether that was during a sort of overnight off shift, during existing planned downtime for the machine, but in any case, minimizing the impact in operations and maximizing the ability of that equipment to continue to run. So you've heard a little bit about Smartinsights and the value it can provide. Talked about a particular customer example where they had a significant improvement in availability as a result of that. So let's quickly go into a demo so you can see Smartinsights for yourself. So I mentioned that Smartinsights was designed for a multi-plant environment. So when I first log in, I see a global view, and I can scroll around the map and see all of the different locations where I have individual plants across the world, and I've got a number of different types of plants here together. I can also see the number of different asset models and the number of assets that are deployed worldwide. And certainly being able to model assets and being able to treat like equipment with a like analysis so that you can compare equipment and contrast equipment performance is a significant benefit. So whenever there's the same type of equipment deployed, at an additional location, it's important to have a common asset model to be able to compare things. When I click into a particular site, I'm quickly brought to a view of that entire site. So this could be a picture, it could be a floor plan, it could be a flow chart through the plant, it could be a CAD CAM drawing of the layout of the particular plant. That's completely up to you as a customer. And I can look at all of the assets that are located in the plant. I can quickly search through them. So if I'm looking for a particular piece of equipment, I can find it very quickly, which is incredibly important in sites that have hundreds or even thousands of assets themselves. I can create dashboards for each particular site that could tell me, for example, how many cycles per day we've taken off the end of the assembly line or anything along those lines. And then for each asset, I can hover over and see what it is. When I click in to one of them, I'm immediately taken to a view that gives me a 2D or could be a 3D image of the piece of equipment, so I can actually visually say, yes, that is the piece of equipment I'm interested in looking at. I can see what model this is using. So this is a CNC mill in this particular case. It's located at my metal fab site. I can see all of the properties for that. And again, I can quickly search through the properties. So if I have hundreds of data points available from a particular piece of equipment, I can find something that I want to zero in very quickly to see what the current reading of that is. So just some basic information about each piece of equipment. From there, using any number of visualization tools, I can create different dashboards and charts and ways to look at equipment. I can query a particular time frame. Let's say I wanted to look at the last 90 days. I can also zoom in and look at a particular piece of time. I could say, for example, just show me the last 30 days. Or if I really wanted to drill in, I can drag across any of these visualizations and quickly get into each of the readings and see exactly what was going on with the machine at that particular point in time. In fact, I can even filter those results. So if I wanted to do something like, for example, I wanted to look up the what the machines were doing when we were running a particular type of job on the machines, I could filter for just that, and then I could look at all of the time ranges where that particular job had run, then be able to drill in further and see what was going on in that equipment. In the background, of course, we can have alerts and notifications tied to particular things happening on the machine, and individual users can subscribe to those alerts as well. And then we can integrate this with other services. So, for example, I can take telemetry in near real time, such as looking at, say, for example, in this case, let's look at the spindle speed related to the amps that are drawn on that. I can take that telemetry data, feed it from Smartinsights into an additional AWS service, such as Amazon Lookout for Equipment, and then I can plot those anomalies. So I can then zero in on times when there is anomalous behavior in equipment. The equipment may still be running. Clearly, it's still producing here, but there may be some anomaly there, which then can be used to fire off a ticket for a maintenance worker or some additional work to look at what's going on with that. And if that is going to lead to a downtime or a lack of availability in the future, that can be used as a predictive indicator to enable operations to continue as much as possible. So that gives you a quick overview of that. As I said, we've a number of different things that allow you to look at sites globally, look at individual alerts, create calculated tags, and have all of those sync back to the additional AWS services. So look forward to the opportunity to have further dialogue with customers with that. So with that, thank you very much for the opportunity for this. And I think then we're going to continue on, and I'm going to pass things over to Rob now for his presentation.
Thanks, John, and appreciate the handover. I think it's a great segue between our two technologies. I know that you sort of illustrated to everyone a big focus on the ML side of things and getting data and kind of making inferences from the data that you capture. And we'll hopefully top and tail that part of the solution with an area that we tend to find tends to get forgotten about a little bit with IoT, in that the actual network of things to put that together. Our business is designed to develop and deploy a solution that is basically an IoT network as a service. And we focus on basically getting data from really hard to reach places in client sites and getting that onto a screen in less than 24 hours. My name's Rob Cumming. I'm the CEO and founder of Urban.io, and have spent a lot of time in these hard to reach places. I don't normally wear a blue vest like this. I normally wear a high vis vest. But we've spent a lot of time in some pretty tough locations around the world, and spent a lot of time talking to the field operations teams and maintenance engineers and reliability engineers about their challenges in kind of capturing data and getting that from the field to a place where they can actually visualize and identify issues with downtime. So the purpose of our kind of presentation today will be to kind of take you through that whole concept and how we get that for them in an ultra low cost format. This slide here is really just to kind of illustrate that there are, in any industrial site, and it doesn't really matter whether it's manufacturing or mining or even actually some commercial sites, they have different classes of assets. And if you were to think about, if I was in a mining company, I'd be talking about kind of on this diagram, we've got big autoloaders and rail and reclaimers and diggers and things like that. If I was in a manufacturing site, it would be the factory line itself. And so that is kind of the holy grail of that site. It's the place where they've probably put in a lot of instrumentation. It already exists as they put the line in, or they bought the equipment. As you start to get it out from the tier one assets to the more peripheral assets, the actual cost and the effort to use traditional wired SCADA and monitoring systems becomes harder. And that could be exacerbated by a number of reasons, but the further you get out from the core assets in a site, the more economically unwieldy it is to actually reach those assets and connect them back into some sort of centralized point. And we need to remember that, and I'm sure many of the people who are watching the presentation have legacy assets and sites, which may have had SCADA and PLC infrastructure put in, 20 years ago or more, and they might even have assets that are scattered around their sites that are not connected at all. And we class these as what we call a tier 3 asset, completely disconnected from anything that is a control system, or they could be even an isolated process control loop that people will still need to basically go and inspect almost every day. If there is actually downtime or that process loop fails, then basically no one knows about it until some bad things happen in that particular facility. Those completely disconnected assets, or we kind of call them the long tail of unloved things, are our primary focus. We are developing a solution that basically allows those assets to be connected back in and participate in the Industry 4.0 or all of the digital kind of automation strategies that businesses are implementing at the tier 1 level, but we can also capture all of the fringes as well. So we kind of work specifically at the other end of the spectrum within a typical AWS customer environment, whereas AWS is predominantly focused at the CIO and in the cloud, we spend most of our time with operations people and field services and field engineers. The main thing that we hear is that the O&M team, especially in a large distributed or dispersed sites, they just need visibility, and it is difficult for them to get that visibility of what's going on with the sites. They sort of kind of went through a number of different use cases and themes within this. We see the same thing, the same echoed themes: preventing downtime, reducing the cost or the frequency of human inspections to specifically very remote sites, ensuring that the runtime and the utilization of spaces or systems or machinery is optimized, and then also improving safety. If we can remove or reduce the exposure of humans to dangerous environments, i.e. don't have to go and inspect something every day or every week, then we can inherently improve the safety and the risk profile of those people in their working environment. However, what we are, and this is the area that we focus on, is that a lot of these spaces that people are looking or have to manage are what we classify as hard to reach. And we have kind of 5 different variables here that kind of contribute to the level of difficulty to reach a place, and therefore the economic challenge it is to connect them. So basically, the more remote something is, the harsher the environment or exposed the end destination is. The fact that the end destination or the asset is nowhere near something that is connected. So a lot of people might say, oh, well, it's connected to the Wi-Fi, and a lot of the places that we go, there's not a Wi-Fi within 500 kilometers, to be honest. So we have a lot of these places which are nowhere near infrastructure that has any form of connectivity to it. And then once again, exacerbated by how old the asset class is. And we need to remember that almost all of the stuff we're dealing with in the world is not greenfield, it's not being built now. And so it doesn't have the inherent telemetry and control systems of sophisticated infrastructure built into these systems. And so everything is a shade of legacy, and many of the things that you might deal with in some of the older sites, some of the sites we're dealing with are like 50 years old assets, or even older than that. And so there is no concept of connectivity involved with those assets at all. And then the final thing, I think it's similar to what John pointed out, people are dealing with disparate sites that are scattered maybe nationally or internationally, and you might be sitting somewhere in the US, or I'm based here in Australia, where even going to capital cities or regional areas, it's quite connected. But there are some of these operations managers have then got a number of sites that might be sitting in Papua New Guinea or some other kind of very, very challenging, very, very difficult to reach country, and far to reach places in those sites and countries as well. So all of those challenges kind of prevent connectivity to some degree. And that's the area that we're sort of focusing on. We hear a lot of people talking about, obviously I'm in the IoT space, and people saying, yeah, IoT is going to fix this. The operations teams that we are dealing with and maintenance engineers already have large portfolios of assets to deal with that are already a challenge for them. So they don't want to deal with another thing that connects the thing and deal with that network of things. That is actually duplicating the complexity of all of the assets that they need to deal with. And fundamentally, what we find, the people that we're dealing with at the edge of your business just want data. They don't want, and they are not network engineers typically, they don't want more complex systems to worry about. And often IT is struggling to kind of help these guys get that simple connectivity to make that go. So what we have developed is what we call a turnkey IoT network as a service. And we actually manufacture our own hardware. So we basically manufacture sensors. That's a wireless sensor there, a vibration sensor. We have a whole range of these different sensors. We develop our own gateways. This is one of our industrial gateways that will connect the sensors. and that then joins into our AWS run cloud environment, and we turnkey that entire stack into a black box network that is, it's fire and forget, it's completely managed service, and we have effectively turned hardware into a subscription service. So we sell all of that on a per endpoint, per month, or per year basis via AWS Marketplace. And then from that, we have basically an API that connects out into the AWS environment to connect the data and flow it through into the business systems or the visualization systems. In fact, John's system that you had before could be easily a target environment for data from our network of things. And we are basically taking away the pain and the anxiety of having to try and deal with a complex, organic, disparate, very hard to plan, and just saying, we'll take care of all of that stuff. You focus at the business end and work out how to extract value and benefits from the data we can now get from you, and keep your focus there. And we'll just do this as a simple solution to consume. So our goal in life is to provide basically a uniform price to connect pretty much anything anywhere in the world. And our starting price, this is not the end price, but the budget price that we say to people to think about is 50 US cents a day is the turnkey cost to start. Many of our customers are paying much less than that. We do volume discounting, obviously at scale for IoT networks like this. And this is a perfect example of one of our client sites. It's actually a electrical distribution network. So basically the power poles that distribute electricity. It's in the Pilbara, which is a very challenging part of Australia. I noticed, I think in the US, there was the highest temperatures in Death Valley, I think in the last week. The Pilbara in Australia is kind of pretty close to Death Valley in terms of its conditions. And there is a lot of mining assets and different heavy equipment in our client environments out there. This is a sensor that's connected to basically a power pole. It's measuring the earth leakage of electricity that may leak into the earth as the parts of the distribution poles actually get clogged up with dust. And it's 50 cents a day to get that point of data to tell whether there's earth leakage. And that's a turnkey price to them to get that. That challenge is the challenge where we are looking to solve pretty much anywhere in the world. We have a caveat. We'll say 95% of the world, or basically we're occupied where people are. So we're not talking in the middle of the Arctic, but we are talking where people are active. That price point is achievable using our solution. So when people kind of, we try to get people to help them imagine hard to reach places. And I think we'll actually just sort of walk through the different components, and then I'll show you some examples of the places we're reaching. Comprising the solution, as I said, we have a whole range of different sensors that are designed to capture different vectors of health of an asset or of a space. I won't go into each one of them, but there is a broad range there. They are all standardized form factor. They have, they're IP rated. They have a 2-year field replaceable battery. We provide batteries to our partners and our customers as part of their subscription. They are field replaceable. They normally happen as part of a typical annual asset inspection. And the installation and commissioning of these sensors is less than 5 minutes. And that is the fundamental premise of all of our solution, is the ease of installation in a retrofit solution. Almost all of the cost in wired solutions is not buying the gear. It's actually the commissioning and configuration and the humans that need to be involved, very specialized humans that need to come in and do that commissioning configuration. And we have effectively removed that. If we are not able to attend on site with our clients, then our clients will be able to have someone who is basic electrical training, and not even, if we're not actually wiring into something, I literally just click and connect it onto an asset itself. So broad range of sensors to look at a whole range of different use cases out there in the field. These are all connecting to, as I said, our own gateway networks. So these are an ultra long range private IoT network we use a technology called LoRa, radio technology, which uses free radio spectrum that is around the world. But we run a private LoRa instance so that we completely control the network, the availability of sensor bandwidth that goes through it, where it's going to be deployed, and we deploy the network on the fly. So as a client comes to us and says, hey, I've got this sketchy place that I need to get connected and we need to monitor these things, we will typically do a desktop exercise with them, using Google Earth or something like that to say, okay, well, this is where we think that the gateways are going to be positioned. If we are in a factory or we have access or proximity to PLC or any kind of low voltage equipment, then we typically will use an indoor gateway like this one, which can be powered via low voltage. You can see this is not connected to anything at the moment. It's battery backup and everything like that. And if we are in an outdoor scenario, the one on the right, we have a solar-powered, self-powered mount. That's an outdoor rig that you can see there, and that could be literally just stood up in the middle of literally nowhere. That picture is actually also in the Pilbara as well, and that is self-powered, self-sustaining, and these gateways are able to form a network that can connect our sensors up to 5 kilometers away, and can connect thousands of sensors. So we can form an ad hoc network on the fly in less than a day that can connect pretty much sensors anywhere that are scattered around the place. It is completely, as I said, private. It's a private network, fully encrypted. It's all over VPNs. We run a backhaul in each of the gateways. They can connect to 540 mobile partners around the world, and we can literally just turn it on and connect, and it will securely connect to our cloud aggregation point in AWS. The final leg of the solution, we provide standard APIs to aggregate data out from our network to different visualization platforms. The platform that I will do a demo on today is AWS SiteWise, and this is SiteWise Monitor that you can see on screen here. We do routinely route data to a whole range of different visualization platforms, but in the case of SiteWise, we find it's a really handy tool that it's basically a managed network reporting and aggregation service that can sit in the client site to run their own data from networks such as ours. It is able to aggregate from multiple different disparate sources of data. So we are one of the constituent parts of the IoT network feeding data to that. And we have developed a asset model converter, which is effectively a connector, a pre-baked connector that dynamically pulls the configuration of our IoT network in the field as it's deployed and builds an asset hierarchy inside SiteWise so we can then assemble dashboards on the fly. And we'll do a demo of that later on in the presentation. So I'll just quickly run through some real world examples just to kind of help visualize some of these, what we call hard to reach places. This is not all of the different types of use cases that we connect to, but just some color and movement to help people understand what now is kind of within the realms of possibility. Disparate SCADA PLC panels. We see literally thousands and thousands and thousands of disconnected, isolated PLC loops. This is obviously a bit more of a sophisticated one here, and you can see that we've got a bunch of our sensors that have been wired into this cabinet. We're literally just wiring into the SCADA panel, and we are piggybacking off the readings that are running through the SCADA. So we're either reading a dry contact relay saying, am I on or off or red or blue or triggered or not triggered, or traditionally open or traditionally closed, or we have a 4 to 20 milliamp sensor as well, which can read a 4 to 20 milliamp output. So just scattering through overflow pits, tons and tons of pits. Flooding is a problem in so many different scenarios, and so flood sensors to just give you a trigger to say this thing's gone off. We also use flood sensors even just to detect levels of water in tanks. Is something overflowing or has it run dry? Very, very simple use case, but super problematic if these are scattered around the place. Tank levels, this is actually a petrochemical set of tanks that have their own sensors on them, once again, not connected to anything. And so we're actually connecting the sensor, the existing sensor on the tank, with one of our sensors that basically harvests the data out of the existing infrastructure and brings it back to base. Motors and pumps is a massive challenge everywhere. There are, literally millions of electric motors, and probably a lot of them connected to gearboxes and pumps. They are not monitored. They do not have telemetry in them traditionally, and so being able to retrofit on, we use a combination of basically a vibration sensor and a temperature sensor to get that combination of temperature and vibration. There's lots of sensors like this around the world. I think most of the control systems have started cottoning onto this. However, none that we can find will connect over multiple kilometers or miles away from the connectivity point. And so we feel like we've found a pretty big niche. We are connecting these scattered assets that are running pumps out in the middle of nowhere, and being able to then predict the failure of a motor or pump in some critical places is super important. We see this all over the place. Anyone who's running manufacturing, mining, or any kind of industrial site will have motors and pumps all over their site. This is a ball mill. It's in a gold mine. It's used to separate material. So basically, ore is coming in, and then they're separating and rolling around in this ball mill to basically get gold particles out of that. Once again, a fairly common and imposing looking piece of kit that is in gold mines, and anything else that's processing ore like that. Totally full of bearings and rotating machinery, and not instrumented once again, even though this is a pretty recent mill. So there are tons of points. We went and Retrofit installed this site, put 50 sensors into this mill in it was about half a day, and connected it. And that was done fly in, fly out without any site. We didn't go to the site beforehand. The operations manager came with us and just walked us around, said, I want a sensor there, I want a sensor there, I want a sensor there. And we were able to connect them in literally half a day. Pumps and meters, lots and lots of meters around the place that are often not connected, especially industrial meters. People have to drive around these sites to inspect the meter and take a reading and then write it down. Crazy waste of skilled resources in any kind of maintenance and uptime kind of outfit. People should be using the data to kind of optimize the operations, not running around capturing the data from a disparate point of measurement. So we have a meter count sensor that connects them. Once again, not rocket science. It's reading the meter, and it's actually relaying the output of the meter back across the wireless network to the central system. And the final one, which I'm going to pause on, this is the one I'm going to do a bit of a demo on, bucket elevators. I'm a recent aficionado of bucket elevators. I was schooled by a 65-year-old engineer on this pretty heavily about a year and a half ago. He took me for a walk through his factory. This is actually in a flour mill, and the bucket elevators are used to transport literally its produce or materials or raw materials up to the top of a process, and then the materials will slide down that process. In many cases, the material that is being transported in the bucket elevator or in these buckets as they go up is dusty, and it can be flammable and can catch fire. In this particular case, this is a flour mill, and flour is flammable and can catch fire, and in extreme cases can explode when it is exposed to extremely high temperatures. And I'll talk a little bit about this, but these bucket elevators, you can see this in this photo itself, these are really old equipment, and they are sitting at the top of a 9-story flour mill shaft, so basically silo, and very hard to reach. Like even the people who are there permanently on site don't go up and inspect this every day. There are about there's like 5 to 6 points on each bucket elevator where it will generate friction if it starts to fail in a specific way, which I'll talk about in a sec. That will cause an abundance of heat, and if it catches fire, then literally the whole thing can blow up, and you can blow the entire mill up. It's a thing. If you go onto YouTube and look up flour mill explosion, you'll be able to see that some photographs of the aftermath of one of these blowing up. The main thing in this is that this particular site is more than 100 years old, and the cost to wire in a similar monitoring system was going to be $10 million to cover the bucket elevators across this. And we were able to I literally, as this gentleman walked me around his site, we literally installed sensors on the fly while we did it. He'd never installed one before in his life. He just looked at me, turned around, he's standing on a step ladder, literally in that just to the side of that photo, and just looked at me and said, "This is absolutely amazing. I never knew we'd be able to do something this simple to gather these kind of 9 points of data that we're looking for." So I'm just going to quickly go across to a demo in a second. Just to set it up, it is about bucket elevators. If anyone has never seen one of these things, they're basically, they are like a conveyor, but literally vertical. They have a motor on the top here, and they have two, there's basically a pulley drive, and there's an idler at the bottom, and there's these buckets that basically rotate around, and the buckets grab material and they pull it to the top, and then it moves out of shaft. And they're designed to just move materials around the site. On either side of these things, so basically there is a shaft going through each of these. It has bearings in it, and bearings wear out and they cause friction, and that will cause heat. It is a potential source of ignition. A worse source of ignition is actually when the buckets slip on the belt and they can run against the side of the shaft here. And you can see some of these, you can see these rotating kind of lines that are on the inside of these metal shafts. This thing's been repaired about, I don't know, 10 times by someone with some pop rivets and some metal. When things scrape, they cause a lot of friction, and there's basically flammable material inside that. So these guys are really, really focused on trying to pick up temperature anomalies and vibration anomalies inside this machinery. And so we're using a combination of a vibration sensor and a temperature sensor. And really just to emphasize kind of the simplicity of this, the reason why they're not monitored at the moment is because it's too expensive to run a retrofit SCADA implementation to all these disparate locations. Our process, and this is literally photographically what happened on the day. We did a half-day desktop exercise with these guys. We had never been to the site before. This is actually the silos on their site. We picked a location for one of our gateways. It happens to be an outdoor gateway here. And we did that as kind of like a half-day planning. Then we brought the right equipment, and we pre-configure our equipment generally before we come out. So it's kind of done as part of the desktop exercise. When you get on site, you don't have to be typing names on your phone and things like that to do that. The gateway is literally assembled to an existing weather station that was on top of that. We just snapped it on. It took less than an hour to assemble that. And that gateway there is able to connect. I mean, this particular site is a reasonably large manufacturing facility. This gateway is connecting things that are several kilometers away from this point. So the entire factory, every floor of the factory, anywhere in it is easily within reach of our wireless sensors. The individual sensors themselves all have a QR code. They are designed to function not dissimilarly to the way that you would typically expect a consumer IoT experience to work. Literally click it with a QR code, type in a name. Because it's all our sensors and our network, we can control the user experience of commissioning so tightly that you literally just scan and click and it will connect, and that's done. So one of the benefits of having a black box kind of system is that we can massively simplify and kind of pre-detect, pre-configure everything to work pretty much automatically apart from naming something. And then we place the sensors onto the rotating pieces of machinery here. This is the bottom of the bucket elevator. So the buckets are kind of rotating around here at the bottom, and there's a shaft here that's turning, and there's bearings inside that. So we're basically putting a vibration sensor on the outside of that, and there is a temperature probe, which is just literally stuck on the outside of the metal. The metal transfers 99% of the heat that's happening inside that shaft. And we're able to infer temperature and vibration, much of what's going on at that point. Then, as I said before, we have a number of different ways to bring data out from our platform. In this particular case, we're streaming the data to SiteWise. Because we have this asset model converter integration, the actual configuration that as we configured the site as we were out in the field, the structure of that site is automatically reflected into SiteWise. So the actual setup of the data structure is done automatically for the user, and then the user just has a list of assets that they were able to select and drag out onto a dashboard. So I'll just demo that quickly now, just to show you kind of the experience and really kind of the rapid getting data on the screen within a day is really the goal we're trying to do here. So just jumping into this demo now, you can see on screen, this is site-wise. I already have a dashboard here that is running. This is, as you saw before, we've got temperature and vibration sensors that are running on the upper and lower bearings, and this particular bucket elevator in this environment is called first damp. And so we're measuring basically the temperature of the upper bearing on each side of the shaft at the upside, and this is the vibration of each of those. And so we're measuring in multiple axes there. Really what we're looking for here is temperature anomaly. So if something gets hot, it's bad, obviously. That's the thing that we're trying to detect, ignition point. Vibration is early warning or an indicator of when things are, vibration typically indicates movement, and also it can be an indicator that friction is occurring, and that will then raise temperature. You can actually see that sitting here where the vibration here is when activity is happening. This is just going over 1 millimeter per second, and you can see that the temperature is actually hotter or is heating up at that point. And what we did notice when we put this in, I'm just going to go backwards in time here a little bit, is that there is definitely a correlation of temperature in this particular north side bearing with the vibration that's going on here, and that is vibrating more heavily, which indicates it's an indicator that there's possibly some wear in that particular bearing, and it heats up when it's moving faster compared to any of the other bearings that are around there. That's particularly anomalous. But really what I wanted to show you today is that how easy it is to actually configure this. And so I'm just going to go in and I'm going to add some additional data to this dashboard. And if I go in here, I'm going to just add to this the upper housing. So on top of the bucket elevator, we place a kind of a ninth sensor, or there's basically a temperature sensor on top, which is actually measuring the outer temperature of the metal housing. And so if I grab that here, I'm just going to pull that across, and you can see that coming into this environment. And if I go and also have a look at, I'm going to grab some other temperature as well in this environment. So I'm going to grab the indoor and outdoor temperature of the environment and drag that on there as well. And you can see we've got some comparative temperature coming in. And these are then able to, if I save that, you can see that obviously this dashboard is kind of happening in real time. You can see then I've got different temperature happening, and I can see the correlations of the upper housing, what's going on for outdoor temperature. It's actually quite hot, cold here in Victoria and Melbourne, where I am at the moment, and then the mill indoor temperature. So this isn't going to give us any particular inferences, but what it's actually going to show is that we're able to kind of get data from an asset list onto a dashboard pretty much in 2 seconds. I'm obviously not, I'm not a network engineer myself. I'm more of a designer. And so this tool, we feel, is perfect for, the sorts of operational users who are not an IT person. They're able to come and build their own dashboards very, very quickly without any specific skills. And it kind of decouples the complexity of the network setup and puts the power in the hand of the people who are actually wanting to see the data, to be able to have a malleable kind of tool set to visualize real-time information very quickly and to kind of assemble it themselves, combined with our ability to kind of get that simple data from the field. So I think that's probably really the thing we wanted to highlight today, is that there are a lot of tools and a lot of technology around that kind of take that complexity out of the IoT space now and really get you as the user to the point where you can actually get material benefit by being able to see the data quickly and not have to go through all that pain of setup. and effort to kind of get the data to the screen.